everyone. It's always great when you get to the room nice and early and then you find that the previous session goes up, like, you know, a good 10 minutes over. Have you all had a really great event, great conference?
Yes.
Fantastic. It's good to see so many of you here. I totally appreciate there's other great sessions on at the moment, and that many of you will have seen colleagues and so on disappear off back home to make sure that they can be at home for their Friday night activities, whatever they may be. I quickly want to ask, while Barvik's getting his network, Barvik's machine just blue screened and it's come back without network connectivity, so he's rebooting again, and we're hoping that that's going to work. You should probably actually try the wireless as well.
Yeah.
But at least it's working? Okay, cool. Did many of you get to Matt Usher's session this morning? Yeah? Quick show of hands if you went to Matt's session this morning. Show of hands if you didn't. Okay, sure. That's really helpful. I love the fact that you three all went to Matt's session. That's good. So this session is about SQL DW. It's a deeper session. SQL Data Warehouse lives in Azure. We're not talking about general data warehouse queries. We're talking specifically about Azure SQL Data Warehouse. SQL DW is the abbreviation for that. There's plenty of reasons why your data warehouse queries are slow, but we're not necessarily going into that. We're looking at the Azure SQL Data Warehouse today. I love this photo. I mean, I get that this is probably like the 15th or something session that you've been to, and you probably haven't really necessarily appreciated the photo that they've used. I like it, as opposed to these photos, which are just ordinary. My name's Rob Farley. I'm a community influencer. Is that the right word? I have a company called Lovespot Solutions, and I've been an MVP for a long time. I've been a trainer in APS-PDW and now SQL DW for a while as well, which is all kinds of fun. So I get to see what people do in the MPP space, that massively parallel processing space, and get to try to teach people about how they need to think differently. There's going to be more on that. This guy over here is Barvik. He works for Microsoft out of Perth.
I'm ready to do my own intro. I look like I'm working over here.
Are you working?
Yeah.
Sure, terrific.
So very quickly about me, data platform, end-to-end, worked for a partner for quite a long time. Hello? Turn? Yeah.
Yeah, you're on. Oh. Is he muted at the moment?
As I unmute, hello? Is that better? So,
For the sake of the recording, everybody, this is Barvik. He used to work for a partner. He's been with Microsoft for a while now.
It is saying low battery. Oh, good? Okay. So, yeah, I've done lots of data stuff. I'm mostly a BI professional, worked with SQL Server and everything else, SSIS, AS, RS, data warehousing, reporting, analytics, visualizations, and so on. I managed 2 consulting teams for a partner until about a year ago when I joined Microsoft. So currently I work with a small number of enterprise customers to help them with their data problems on-prem, on the cloud, and for hybrid scenarios. That's it.
I think the main conclusion for this slide is we both need new photos.
That's an old picture, yeah.
Yeah, mine's an old picture
You just
too.
grabbed it off my LinkedIn.
They're both bad, yeah. But anyway, on the agenda side, I kind of figured that we'd start with the abstract and basically just kind of highlight the bits and how that makes for today's session. So quickly, Azure SQL Data Warehouse offers some great technology to help you scale out. Understand it's scale out, not scale up. It's a different kind of paradigm for producing that power. So I say loading data can be lightning fast and analytical queries can be super quick. But what about when it all slows down? Let's explore some of the internals of SQL DW, show you where things can go wrong with loading, transforming, and querying, and how to get the performance that you would expect. Let's highlight some bits. Barvik's going to cover the basic concepts of what's going on with SQL Data Warehouse. And I've put a thing here to say, but you all got it this morning from Matt Usher's session. I think you three got it from Matt's session. The rest of you, I'm going to assume, are probably quite across the basic ways that SQL DW works.
Can we check quickly? Anyone who has no clue what SQL DW is, or very little? One person? Okay, good, because we're gonna rush over the basics and then deep dive. So
Yeah.
okay.
And the key takeaway bit of that is that SQL DW is there for scale out. He's going to look at all kinds of things around that. He's going to talk about why SQL DW is so fast. And it really is. Please understand that the topic of why is my SQL DW query slow, it shouldn't be. It should be fast. And you probably find that it's fast. The feedback that I always get from customers is, oh my goodness, it's quick. Except that they kind of make a face when they say that and go, usually. And sometimes it's really not. Sometimes it feels painful. Sometimes they're going, wouldn't this be better on a regular SQL box? And the answer is often, well, yeah. And if you're looking at SQL DW for your data warehouse simply because it's a data warehouse that you're wanting to do, but your data warehouse is small, then maybe SQL DB is better. Because SQL DB aligns with SQL Server on-prem, as opposed to SQL DW aligning with PDW on-prem.
Yeah.
So all those things that you do for your data warehouse currently on-prem, or earlier on-prem before you looked at Azure for your relational environment, maybe actually SQL DB is a very good choice for that. It's just that it's very limited in size. It doesn't scale out. It only scales up. Well, look at this. SQL DW is fast, right? It really is. Please understand that. It's just that some of the choices that you make can slow things down. So I'll explain a bit about what happens when a query runs, about the way that it executes. Bhavic's going to highlight with a lot of that with a demo. But I'm going to then jump in and start saying, now here's where the things that you choose, those design decisions, those query forms and all kinds of things, the things that you know about data that it doesn't know by default. Those times when the defaults aren't going to cut it, and you'll find that things just don't work as nicely as you would expect. Okay? Which is, in some ways, the main part of the level 400 talk that we're looking at. Because at the end of the day, if you've chosen SQL DW, you deserve to have good performance. You're paying for it. You should be earning that. I'm going to pass the
Thank you.
the clicker over to Bhavik, and I'll stand over here and make smart aleck comments as he explains some stuff.
Okay, guys. So thanks, Rob, for the intro. I thought it would be good to just have a quick overview of some of the data services, what we're calling Quintana Intelligence, which you're probably familiar with. And where does SQL Data Warehouse fit in? So it's right there in the big data stores. So understand that it is designed to handle extremely large volumes of data and structured data. It can also handle unstructured through Polybase, which you may be familiar with. And in fact, for the demo today, that's what I used to load my data set up. So it's a big data store. And as I jump into some of the next slides and the demo, we will show you why for trivial volumes, so even low millions of rows are not enough to get the advantages of SQL Data Warehouse. At a very, very minimum, you need about 60 million rows to even take advantage of some of the technology that's in there. So let's jump in a bit further. I wanted to talk about SMP versus MPP. So SMP, symmetrical multiprocessing, is your classic single boxes. So this is where Rob talked about scaling up. So scaling up means chuck more resources on it. More CPU, more RAM, but you can only go so far, right? And it starts becoming quite costly. I'm having these situations at customers right now where they're saying that a 64 gig stick of RAM for their hardware is quite expensive compared to a 32, so they can't scale up anymore. So I'm not going to cover all these points. You can read this later. You may be aware of them. But MPP, massively parallel processing. So as Rob mentioned, when you can't scale up anymore, you scale out. This is not a new concept. We've been doing it in other systems for quite some time. In the big data world, for example, Hadoop has been using that same concept, lots of commodity servers. So the idea is there you have shared CPU and memory, and over here you have dedicated CPU and memory for each node. So let's quickly explore what's in the box for the couple of people who are potentially new to this paradigm. So we have, I guess, two components. You have a control node, and then you have compute nodes. So the control node is basically your access point. That's the thing that you can kind of see and what you connect to. And it's kind of the management interface, and it handles coordination of activities between itself and all the data nodes. the compute nodes rather. Each of them actually has a SQL database associated with them. That's kind of simplifying it. We'll jump in a bit more and explore that in detail. So really, what we need to know is that any SQL DW environment has 60 databases at the compute node level, and also another database sitting up there on the control node. And this is an important concept, because when we discuss distribution and partitioning and skew, you need to remember that 60 is that magic number that doesn't change. Okay, so let's dive in a bit deeper. Those compute nodes are all backed by Azure Blob Storage. Now, that is not managed by you specifically. You just provision your environment. You can scale up and scale down using either the slider on the portal. You could use PowerShell. You could use a REST interface. You could use TSQL to simply dial up and dial down your compute nodes. So let's go a bit deeper now. We also have something called the DMS, the Data Movement Service, and this is a very important thing to know about. We don't interact with it directly, but what we'll see later, and Rob will go much deeper into this, is we're trying to avoid kicking in that data movement service where possible. Because this is a parallel system, where you've got lots of nodes there are situations that require data to be moved from node to node. And that's an expensive process, and it slows queries down. So we will discuss later how we can avoid that situation. Now, it is possible to actually load data from blob storage directly, if possible. So this is where that polybase concept comes in. So it's possible to actually use external blob storage, which you provision yourself, and actually have even unstructured data potentially from a Hadoop environment accessible through your TSQL. So your application or user connection, as I said, is at the control node. There'll be a slide in a second giving more details on that. So compute, the important point here, so some of the value props for SQL DW, and something that we consider at Microsoft unique compared to some of our competitors, is the ability to scale up and scale down when required. You can even pause and stop the data warehouse. So by default, you get a DW400, that's 4 nodes. You can scale that up to 6,000, which is 60 nodes, and you can scale it down to 1 if you want. You can also pause the data warehouse. So in the portal, for example, you can just hit the pause button. That stops charging you for compute, but it doesn't stop charging you for storage. So just be aware of that. You will still pay for storage, and the storage is also geo-redundant, so you'll pay for 2 copies of storage, and if you've got snapshots on every 6 hours, that storage also counts. So you can actually go back in time and restore a database. So just be aware storage costs can pile up, but at least you can stop the compute, and you can dial up and down to handle different sizes of workloads. So I've already talked about that. You can add additional storage without incurring compute costs. Now, this is an important point because some of our competitors, for example, if you just need to add more data as your data volume grows, you are forced to buy more compute because they essentially add more VMs behind the scenes, and you get compute even if you don't need it. And finally, we decouple this. So that's basically the final point now. I've kind of made that already. If you decouple storage and compute, you can actually build more effectively, and it's more cost effective. So the control node, it's the endpoint for connections, standard SQL endpoint, TCP port 1433. You can connect from Management Studio. It'll pop up a few errors because it's not the traditional SQL server, so you'll get a few warnings coming up, but it works better from SSDT, Visual Studio, and it coordinates all the activity, as I've said. So your compute nodes are down there. As we've said, we can change the number of compute nodes, and what we'll be doing here is changing the DWUs, and I'll talk about DWUs in a second. So when you increase the DWUs, you will get an increase in the number of compute nodes. So as I said, DW100 is 1 node, DW6000 is 60 nodes. You might ask why they've gone with hundreds instead of 1, 2, 3, 4. I've asked the product team. It's actually, in case they want to add SKUs in the middle, they've got some leeway to move there. So for example, you could have a 250 or something like that. Don't take my word for it. That's not an actual thing, but that's what I've been told.
They also sound more impressive. If you're saying you're starting at 100, that's not
sounds good.
It's the same with game shows. They tend to give points in oh, here's 10 points for you.
Yeah,
exactly. They just go, here's 1 point. It doesn't
1,000 points, Rob. Well done. Okay, so DW. Again, this is one of those interesting Microsoft inventions. At least it's better to understand than the DTUs, for example, that you get in SQL database. So it's a data warehouse unit, and at least it's pretty easy. Like I said, 100 to 6,000. Not every multiple. So for example, there's no 300. And we'll explain why when we get a bit deeper into how the backend is architected, because there needs to be a mapping between compute nodes and storage. So how many do you need? Well, the official documentation will say start small and increase as you go. there is no one size fits all. This is the same as sizing a SQL Server or any other kind of data environment. It depends on the workload patterns, the data volumes, complexity of queries, number of concurrent users. There's lots of factors, right? So start small, see how you go, try some workloads, and then you can scale up. Now, the scaling is really good. The changes are applied generally within 5 minutes. They're aiming to make that quicker, but the product team themselves has said they're aiming for an internal SLA of 5 minutes or less. So drag the slider, hit the code, and it will change.
I was curious, have any of you got experience with parallel data warehouse, APS? No? That's kind of the on-prem version of SQLDW. You would have 2 compute nodes, each with 8 distributions within it as the base level. And then if you filled that up and needed to extend, you would buy a whole bunch of new kit that would get slotted into the rack that you'd bought, and you'd end up with half a rack or at least, or maybe 2/3 of a rack, depending on your vendor.
Yep.
But the process for being able to scale that out further involved having to move all the data, well, half the data onto the new disks that you just inserted. SQLDW is quite remarkable in the fact that you can scale your DWUs within 5 minutes. When it first came out, all the PW people were just like, really, how are you managing to do that? Because surely you need to copy data around, and Barbara's about to show you some examples of what actually goes on when you do that scaling.
Yeah, thanks, Rob. And it's another point I've remembered. So SQLDW is kind of new. It's at least 2 years old now, if I remember correctly. But the idea and the technology isn't completely new. It started in the PDW days, so Parallel Data Warehouse, which then got rebranded as APS, Analytics Platform System, where they allowed you to have Hadoop environments in one, what do they call it, a region? Yep, region. And column store technology, which is now popular and in many products, actually started in the APS world. That's when it first got released. So this is quite mature. It's not like something that we just came up with recently. Okay, so if you, for example, took a DWU 200, so a 2-node environment, going from left to right, we've got the engine, so the control node which we connect to, 2 worker nodes, or data nodes. No, let's call them worker nodes, compute nodes. And we said the back end is Azure storage, right? So blob storage. Now, I mentioned that there were 60 databases behind the scenes. So when you actually scale, you get compute nodes being spun up, and they get remapped. So at the moment, with this architecture, I've got 2 worker nodes. You can see the blue box surrounds 30 databases here, and another blue box at the bottom surrounds the other 30 databases. So internally, it goes worker 1 is mapped to 1 to 30, worker 2 is mapped to 31 to 60. If we were to scale that up to a DWU 600, now we get a remapping. We've got 6 worker nodes, and you can see now that each worker node is now mapped to 10 of those databases. So obviously, when you ramp up to the maximum, which is currently 6,000, you'll get a 1-to-1. 1 worker node against each database. So you're getting more and more parallelism. Now, we had a quick discussion yesterday about I/O. Now, that's something you don't have to worry about, because effectively, all of Azure works this way anyway. The storage is sitting on special storage infrastructure, right? And it's all mapped virtually. So you don't have to worry about, well, if I have 1 node talking to lots of databases, is that going to be slow or whatever? It works as fast as it can. Okay, so query execution. Rob, you're going to talk about this while I make sure the demo is still alive.
Yeah, so...
Do you want the clicker? Have it anyway.
No, you have it, sorry.
Okay.
So on that last slide, the clue as to why 60 is hopefully fairly obvious. The fact that you can divide 60 into 1, 2, 3, 4, 5, 6, 10, 12, 15, etc. I just don't want to think more than that. But that gives a decent range of options. If they decided to start with 8, then you can't really scale that far. But one thing that is really quite important to understand when trying to work out why queries are going slow is what's actually going on when you run a query. And I want to spend a bit of time on this as well, while Bhavik's making sure that the connection works and so on. So, as Bhavik mentioned, you've got a control node and a whole bunch of compute nodes. The compute nodes are doing the work, but the control node is where the MPP query optimizer sits. Okay? We actually have 2 stages of query optimization to go on, right? Essentially, we have something that responds to a distributed SQL query. In fact, if you start a query in Visual Studio, SSDT, you'll see that the query actually says PDW SQL query 1.dsql. If it doesn't, you probably haven't made a proper connection to SQLDW, because you can have SQLDB instances and SQLDW instances. You've got to make sure you're connecting to the right database and all that kind of stuff. And certainly when SQLDW first appeared, the newsgroups were, forums and so on, were full of questions saying, I'm getting this error, and it's just like, yeah, okay, you're just not making the connection properly. They've fixed a lot of that up. But if you remember from the earlier days, if you tried it, a year and a half ago, you may have fallen into that trap. So you submit the query. Management Studio sees it just as a regular query. It sends it to the control node. The control node says, well, how am I going to do that? Remember, the control node doesn't have data. It has metadata. It doesn't have data. It needs to be able to say, right, you've asked for this query, but this table that you're referring to is not one table. It's 60 tables, one per database, right? It needs to be able to go, hang on a second, you're trying to join, well, potentially this row in this database with that row in that database. That's tricky. You might have 1 billion rows in that table and 50 million rows in that table, and it's got to figure out how to do that join. So it needs to be able to say, well, hang on a second, my data is distributed across these databases. Chances are that row and that row are not in the same database, which means that the compute node, any of the compute nodes won't be able to actually pull both rows into RAM and do the join, right? Like any computer, a compute node has its RAM, and to be able to do, well, to see any data, that data needs to be in RAM. And this is a problem. If you distribute a database because you have a system that you need to roll out against multiple customers, and you go, okay, we've got a database per customer and maybe a shared database of data that they all can join to, you know that if you need to run a query across all of them, that data is spread out across a whole bunch of places. It's the same kind of concept with this, except that you need to do joins and all this kind of stuff. You need to say, count how many orders I've got. It goes, well, I'll have to ask each of those compute nodes for how many they've got and pull that to somewhere centrally, which is typically the control node in that scenario, using a DMS move called a partition move, it's just what it's called, so that it can then do a sum of that in the top, right? And Barvik will show you in a minute about the fact that we have an explain plan. And I say an explain plan, it's the MPP plan, but you go explain and run the query, and when you run all of that, you get a chunk of XML back. It doesn't look pretty. It's a chunk of XML, and it's got a series of steps in it. It'll say, create me a whole bunch of temp tables, move this data around, then do this, and run this query on there, and either at the control node or on the compute nodes, and move that data around here and there, and eventually work out how to make an answer. It's the stuff that if you were to try and scale out, you would have pain. Oh, the web guys have it so easy. They just have a stateless machine and they spin up new web farms and it's easy for them, right? And they look at databases and go, why do you have so much trouble? And we know you're here today because you know that it's hard to scale out. The technology around the explain plan works out what needs to happen. So then it comes up with these instructions. Run this query on the distributions, for example. And then each distribution is a regular SQL box. It's told, oh, you need me to run this query with lots of subqueries in it and bad aliases and all of these kinds of things. Sure. And it says, and then do something with the results. It goes, oh, sure, not a problem. But that's a regular SQL box. And you get regular SQL plans. And that's interesting because those regular SQL plans are hard to tune because you can't query that. But also the shape of those individual query plans are affected by statistics that are on those individual databases. I've said nodes, it's really databases. So the database will have one quick second. So each of those databases has auto-create stats turned on, so that if you haven't created your own stats, it will start generating its own, and the communication between the stats on the compute nodes, on those databases rather, and the stats on the control node is certainly a point of potential tuning that you need to be across. What was your question?
Probably this is a very basic question. I'm trying to draw parallels with what we do in the relational database engine and with MPP database engine. Is there any correlation with how a SQL optimizer works in a regular database engine as compared to MPP? And also probably something like explain plan, and is it something like if in a regular database, what would the scale of processes? Why are we writing into multiple databases?
Why are we writing to multiple databases?
Is there any parallels you can draw between?
So the question is, SQL to deal with sounds really great, but how does it compare to what goes on when I run a regular query on an ordinary SQL box? What kind of parallels can I take between the way that I tune a query in ordinary SQL compared to how I tune a query in MPP? And by all means, there are parallels, and we'll be looking at that.
Yeah.
At the end, ask again if
again.
you've still got questions.
If we've done our job properly, it should answer your question. If not, ask the question again.
So, Bhavik, why don't you jump into your demo and show
Let's
a
do
whole
it.
bunch of things, including explain plans. I don't care if you don't show the SQL plans, because they're very much hidden. There's only so
Yep.
much control you can have with
Yeah,
them.
we see how we go for time.
Just a quick one, not a sidebar, but
Yep.
you know your 60 databases underneath?
Yep.
How many DTUs does each one of those have?
It's, yeah, it's not,
Does it work like that? No.
it's not formally done like that.
Oh, okay.
Yeah.
You can't set that,
Yeah.
No, you can't set it, but I was just wondering,
but
they must all be the same when it's...
it's kind of like a middle range one, but I can't confirm, because I can't remember if it was something that I asked about and didn't get an answer that I liked or whatever. But I think essentially, as you scale the DWUs, when you've pushed the DWUs to the max, it will also have pushed the local DTUs up, because it doesn't make sense to be saying, hey, I want the maximum DWUs, and to not be having the maximum DTUs.
Yep.
So I think that they're kind of attached, but I haven't found that documented anywhere, and it might not be the case. And actually, Matt Usher on the product group is probably a good person to ask that question of. If he turns up, we'll ask him.
Yep.
But you know.
Another point on the DWUs, it's not only the number of compute nodes that you get other limits that are pushed up. So for example, the number of concurrent queries, where does it kick in? Is it 1,000? Where it reaches 32, which is the maximum? I forget. It's documented really well. So, you know, on the lower DWUs, you get a lower number of concurrent connections, or concurrent queries rather. If further clients connect, those sessions will be queued up. And when queries finish up and slots become available, then they execute.
The kind of throttling that Barbie's talking about is also around the data movement, and the fact that when you've got a query that runs and it says, okay, actually I want to be able to make sure that this row is in the same place as this row, so let's move one to the other or whatever. There's communication going on between the compute nodes using temp DBs on those individual 60 databases.
Yeah.
And at a really low DWU, it throttles how much network bandwidth that can use, because this is network bandwidth just within an ordinary Azure data center, and it doesn't actually want to be pushing that to the limit and potentially interrupting something else that's going on if you really don't care, because you've only got a DW 100 set. But yeah.
Cool.
Do you want to jump into your demo?
Okay, so let's jump on to the demo part. So I'm going to run through all of this, basically explaining through practical examples the stuff we've been talking about. So let's try the magic flick over. I think it's number 5. It's number 5. Okay.
Oh, yeah. Is that yours?
So yeah, that's me.
Cool.
Can you read that, guys?
Yep.
Okay, I'll zoom up. Just let me know if you can't see. So the first thing we're going to do is run a command, dbcc pdw show space used. And you can see a lot of these are prefixed pdw because they did come from the on-prem appliance, as Rob has mentioned. So let's run this one, and we'll get some output. Excuse me. Oh, sorry, I've overselected there. My fault. Okay, so let's just zoom up there. Okay. So this is just for the entire environment. It's high-level information. You can see reserve space, data space, index space. Those are all in kilobytes. So you get a bit of an idea as to what is sitting on each node/distribution. So for the moment, I think the 2 columns on the right are the important ones. You can see the node ID and the distribution ID. So there are always 60 distributions at the moment. Those are your 60 databases. And we should find there are only 4 nodes. So I've kept this the default size, DWU400. So I should have 4 nodes. So if I just unzoom here and quickly scroll down to the bottom, I should see 60 rows, which is good because I have a total of 60, so bottom left there, 60 rows for the 60 distributions. And you can see the node ID, I've got 1 and 4. I'm not going to scroll through all of them, but trust me, they're 4 in this case. Now that's kind of useful, but let's go a little bit deeper. So let's look at a particular table. So we can give an argument to that particular query, and it gives us 2 more columns. It's actually, did I run that? Execute. Yep. So now it's giving us number of rows, which is actually now giving us a bit of an idea of how our data is distributed. Now, this line item table, it's not really important what it is. I've just loaded up a 10 gigabyte TPCH dataset. TPCH do a lot of the benchmarks in the database world, and I didn't want to use AdventureWorks. So I've got about just 65 million rows or so. So it happens to be reasonably well distributed. You can see some are about 1 million, and some are sitting at around 990K rows. And this is kind of the magic number-ish. So something we haven't mentioned yet is, by default, SQL DW will use column store indexes and column store compression. But column store compression doesn't just apply automatically. There has to be a threshold to make it efficient. So the product team have actually played with lower and higher thresholds to actually kick in column store compression. And they've come up with a number of around 1 million rows. So that's where they feel they get a good balance of performance versus the overheads required to actually manage the column stores. Because remember, behind the scenes, who's unfamiliar with column store and some of the internals? You guys are fantastic. Okay, great. So
well, otherwise they'd be in Sunil's session.
They'll be in Sunil's session learning about that right now, exactly. Tough competition. He is the column store guy, or one of the column store guys. So very briefly, you know how you've got delta groups. You've got a delta table, which is a row store. When that reaches a certain threshold, it gets compressed and moved into the column store. So managing that is not really efficient with low volumes of data. And as I mentioned, you want about 60 million rows to take advantage of column store compression, because that 60 million gets spread across 60 nodes, so 1 million each, and that's where you get that magic number. So I wouldn't even consider using SQL Data Warehouse for smaller numbers of rows. It's just not going to give you, or you have, I mean, there's no option. It's 60 databases regardless. So just bear that in mind. Now you don't have to use column store compression. You can use your standard B-tree type indexes. You just have to specify that when you actually create the tables. So you've got the option there. Okay, so we've had a quick look at one of the tables. Let's actually look at something else. Now, this is all well documented. All the show space used, everything I'm going to show you today is documented pretty well. So I have a custom view which has been set up prior, and from this custom view, I'm just going to grab some information. So let's run that. Okay, so this time around, I'm getting a fair bit more information. So I'll zoom up here, and I'll run through. So let's start at the left. Database name, schema name, table name, all very basic. So there's a number of RF tables here. These are just Rob's ones. So he's taken my very nicely distributed data, and he's made it not so well distributed, so we can demonstrate some of these concepts to you around performance degradation. Now, another point I want to make is we market this solution as being almost lift and shift. If you have a SQL database which is getting really big, you can move it into SQL DW and happy days. And part of that is the fact that you have a very similar TSQL surface area. So it's not the same surface area, but you have wide coverage there. So the idea is, if you're familiar with normal TSQL and databases, you can transition over to SQL DW, and there's less friction. The challenge then is you can't use all the same principles you've learned around performance tuning that you normally would use in a normal database. So this whole concept of distributions and column stores, well, column store does exist, but the concept of distributions and spreading data around and so on just doesn't exist. And skew is not that much of a problem, really, depending on how your environment is considered. So this is why we're really talking about this today, because it's one of the traps people can fall into. You know, you just move everything across and you accept the defaults, and things might not go according to plan. Okay, so you can see that I have distribution policy name there, round robin versus hash. So this is another concept we want to talk about. The default distribution policy is round robin. So round robin says, as rows come in, I spread them out evenly, right? One by one across all those 60 nodes, and I just keep going round and round and round. So that's great. You will be guaranteed to get great distribution because it keeps spreading them around. But that doesn't necessarily mean that queries are going to run very, very well because effectively they're just scattered out at random. So if you put a bit of thought into it, you can use hash distribution instead. So if you use hash distribution, you will choose a column to hash. Obviously, it'll be hashed to some value, and that hash value will be put on a certain database. Now, the idea is you should be using hash distribution for the same sort of keys you have on tables that need to join together. So if I have a fact table in a data warehouse that has a lot of queries that join on customer ID or some customer key, and there's another table somewhere else, a customer table itself that needs to do the join so people buy stuff and we want to know who the people are. If you hash on that customer key, those rows with that same key will be sitting on the same databases. So what happens is we minimize the movement from the DMS servers. So if, as Rob was saying earlier when he was explaining around data having to come from one database to another, you don't know what that is unless you can move that around to do the join. And you don't want to have to move it around, especially if the lookups you're doing are on large tables. Now, I will say that this will be improved in future. I can't disclose yet, but some stuff is going to come out that will make this problem less of a problem.
You only do it on one column, right?
Yeah, only on one column.
Yeah, a lot of people ask about whether you can have a multi-column hash. The problem is the fact that a hash function, by definition, says let's take something and spread it out as far and wide as we can. The idea being that you know, it's nicely distributed. If you've got a bunch of random values here, you want to be able to spread them out pretty evenly, you know, as feasible. The thing is, the fact that that means that if you've got like customer 1 and product 3, and you've got customer 1 and product 2, they're going to end up on different databases.
Yeah.
So as soon as you've said, as soon as somebody says, can you hash on multiple columns? It's just like, well, you know, if you could, you would actually be losing every benefit.
Yeah.
Right?
It's more along with partitioning than
It's a lot more like, it's a similar kind of concept in the fact that some rows go here, some rows go here, some rows go here. Yeah. It's just that with partitioning on a regular SQL box, it's still all completely accessible. And the issue comes around skew, about being able to say, are we doing evenly or are we hashing? And I've got an example coming up on that. Or and around joins and aggregates, where you're saying, if I want to join two things, like that example that I gave where some ISV who has a number of customers, what do you think about WordPress, right? If you have a WordPress-hosted WordPress site, it gives you your own database. It looks exactly the same as somebody else's database, except it's got your data instead of their data, but the structure is exactly the same. You'll have a table of blog posts, and you'll have a table of you know, pages, and you'll have a table of comments, and exactly the same as somebody else's. The structure is the same, but the data is different. You can join to your stuff because it's there. If you're trying to join to somebody else's stuff, well, that's complicated. So by keeping all the customer data in the same spot, you can actually find that your joins will work better. More on that as we go. One quick second. Your question?
It's probably a bit of a strange question, given the presentation, but is Microsoft going to try to move away from having to do performance tuning on those databases, because a lot of products are going that way, like Snowflake or BigQuery from Google?
So the question is about whether this will become self-tuning in time.
Yes.
Again, I can't disclose, but just say improvements are going to be made. So I was in Seattle last week at our internal training, and I spoke to the group program manager of SQL Data Warehouse, and he specifically talked to me about some of these improvements. So I can't say that it's going to be fully automated, but there's going to be a lot of improvements relatively soon under the covers to make some of this tuning a bit better. But it's, from what I'm hearing, a lot of the investment right now is around increasing parallelism and internally making good choices around which queries should be run when.
He's already said way more than I would have done. For the most part, it comes down to being able to look for recommendations. There are all kinds of things you can do to be able to try and work out how to avoid the pain. We'll show you some of the pain as we go, and how to resolve that. And you'll see that for the most part, you don't actually, the amount of performance tuning that you need to do is minimal.
Yeah.
It's about being able to come up with a good design because you understand the paradigm of MPP. If you've got that in place, you'll see that most of the things that I go through as to reasons that I see that people have bad performance on SQL actually start to disappear, because I'm hoping that as you look through them, you just go, well, that makes perfect sense because of what you just said.
Yep.
And that's where it becomes, it's deepening your understanding of SQL to a better level so that you can come up with a good running system. You had a question, Lace?
Yes, please. Basically, my question was actually a follow-up question to the double hash.
Sure.
So, like, from the guidance and all that, hashing against your joining column is probably a great way to distribute your table. What if you have like composite keys? Like we have a bunch of tables with composite keys.
Sure. So the question is around saying it's good to be able to join so it's good to be able to hash on your common join columns and so on. What if you have composite keys and you're typically joining on composite keys? How are you going to handle that? You've got two choices. One is to be able to effectively create a column which is your composite key made up of both.
Yeah.
But also you could just pick one of them, because if you think about it, if you've got customer 1 and product 2, and that's what you normally join on, if you hash just on customer 1, well, on customer, so that all customer 1 stuff is there, no matter what the product is, it's going to be in the same spot. So you'll get the same benefits by hashing on just one of those composite keys as you do on both. The only thing is about the skew. If you find that by picking one of them over the other one, the skew is worse, then sure. If skew is a problem on both of them, come up with a composite column, which is something like, a binary form of that plus a binary form of that that's concatenated that you can easily join on, that you then do the same on the other table so that you can make it a single column join. Does that make sense to everyone? Go on. You could put a non-clustered index on the other one, I guess, but actually when you think about column store, non-clustered indexes come into... So his comment was you could just put a non-clustered index on the other column.
As well as the column.
Sure, but actually when you think about hashing, you have the hash of something which is like a partition key, and that just sends that row to wherever. And then on that particular database, they're not actually in order of customer key or whatever, because there might be dozens of customer keys on that one spot. We'll look at it more as we go.
Yep. It's a really good question. So just to finish up this one, you can see my index type. At the moment, these are all set up as clustered column store, even though there's some very small tables like 5 rows and 25 rows. I was just a bit lazy. And we've got some row counts and space and so on. I won't dwell too much more on this one. Let's move along. Okay, so next up, I just wanted to have a slightly different view of how the space is distributed. So let's run that one. Okay, so this is just basically per distribution. So it's a different granularity. So if you just wanted to look at the total rows on every distribution, you can run that. And you'll get a similar set of columns, but like I said, a different granularity. Now, the last one I wanted to talk about, and this is a very interesting one, is column store density. So I'll just quickly show you the definition of this view. Should have kept it open. Okay, it's a longish view, but again, this is documented. It uses, again, some of the internal procedures we have. So ignore all of that stuff. But you can see that I'm just joining here to a bunch of the system views we have. So sys.pdw nodes, column store row groups, et cetera, et cetera, et cetera.
When you say internal stuff, these are just standard DMVs. You can query them, no problem. You don't consider that this is some secret internal thing that you can't access.
That's a good point. I've used the wrong terminology.
I'll show you queries that use nodes, column store, row groups just by itself, not joining, not making a nice view across it. Barvik does. Oh, you just said you were lazy. Let's go with that. Barvik's laziness is that, no, you can, by all means, you can use views that make it a nicer experience for you. Or, it probably depends on how you currently use SQL Server in general. If you just use DMV straight, then great. If you use customized views across it, then that's fine too.
Yep. Work smart, not hard, right? Okay, so I've run this custom view, the lazy view we'll call it. And this is actually giving me a larger number of rows. So look, you can see the table names there and so on. But this one is really telling you about the structure and the health of your column stores. So let's just briefly touch on some of these rows. So I'll zoom up here. You'll see my table partition count. It's gone off the screen, but it was 1, so I have not partitioned this. Rob will go into that because partitioning can cause you more problems on a parallel environment than it would with a normal SQL database. So partitioning is a good thing in many scenarios because it helps with management, right, and backups and all kinds of things like loading, switching partitions. It's very fast. But with PDW, because of that magic 1 million row number, if you partition, you're now breaking that into smaller pieces and you're separating it out into different smaller sizes. So you're actually now breaking it up into even more pieces and having less of a chance of getting column store compression working because you've got even lower numbers of rows per partition. The way column store works is if you partition, that's a dedicated row group. So it could cause you problems. Rob will go into more detail there. What's interesting here though is this view is giving me like the largest sizes of row counts. So it's actually a good idea to potentially do that so you can see how well distributed you are. You'll see some interesting things here. Now, what this view actually does is it takes some of the flags internally. So for example, you'll get a column which is like 0, 1, 2, 3, which tells you what state a column store is in. So invisible is something that is currently being converted from a row store to a column store. You shouldn't see that often because it's something that's happening right there and then, and that conversion shouldn't take incredibly long. But I think some of the other interesting ones here, as I scroll to the right, are this concept of open row groups and closed row groups. So an open row group is that delta store, which is where rows come along until it reaches a threshold and gets put into the column store. So if you see open row groups, you can see I do have some rows in here. Closed row groups are ones that are not accepting any more rows and are to be moved into the column store. So just be aware that this information is available and it does give you a lot of information to be able to understand distribution and potentially some tuning. And finally, I've got compressed row groups here, which are actually already compressed. I think we're kind of getting close to time here, so I'll move on. Okay, so let's show you how you can actually dive into queries and what queries are doing. Because we talked about MPP plans, we talked about SQL plans on individual nodes. So I have a random query here. It just gives me trade revenue between some countries for 2 years. So I'll run that again. Actually, I'll run it another time in a second. So I wanted to talk about this option label here. So at the end of my query, I have this thing called option label equals ignite test. Let's just change that. I'll make it ignite real, and I'll rerun that. So what this is going to do is label the query so that when I run some DMVs, I can actually use that as a filter and just grab the stuff that I'm interested in. So let's go take a look. I'll come over to my monitoring here, and I'll scroll back up. So to start with, I could just say, look, let's use this DMV, DMPDW exec requests, and I get a whole bunch of information coming back. But this is everything that has been run recently. So this is where that label can become useful, because I can change that to real. I don't have case sensitivity on. So if I ran that, there it is. I've got one row coming up, and that represents the query I just ran. So you get some things. I won't zoom up. You've got start time, end time, elapsed time, and some stuff there. Now, there are other columns available to help me actually narrow that down. So they do have a status like running, cancelled, etc. So I can actually, further filter if I want to. I haven't here, but you can also, for example, look at, ones that have taken a long time to run, where the total elapsed time has some threshold and so on. And in this case, I was potentially ordering it by submit time. So show me in order, in the order at which the system received those queries. So let's move along. The important thing here is I've got a request ID. So I actually will zoom. The bottom left there, you can see the request ID, QID 3227. This is something that I'm going to need to pass to the next one in order to get more information. So let's replace that. Let's run that. Okay, so sysdmpdw request steps. This is going to take that individual query, and it tells me all the steps which I've ordered by, the step index. And this is now getting into some of these theoretical concepts that Rob talked about. He talked about temp databases potentially being created and data having to potentially move around. So we can start seeing some of that now. you can see, as I zoom up here, what operation that was. So there I've got some on operations, I've got broadcasts, move. This is some of the stuff we talked about now, and we can start diving in. And you can see where it was, on the control node, or was it DMS. Start time, end times, etc. All good. Let's continue. Again, I'm not wanting to run over and not get into the skewing stuff. So I can get further here. I can say, okay, let's actually filter on a particular step if I wanted to. So over here I've got 19. Let's run that. And you can see even just step 19 had a lot of queries. Because again, it has to be on all the nodes, right? So we have quite a few rows there. Now let's actually look at the execution plan, right? So distribution ID, I'll just pick, I'll pick 81 here. Okay. Okay. So I've got a block of XML that's turned up down there. And that might not be that useful. So what I want to do is actually paste that somewhere and take a look at what that looks like. So I'll just copy this.
Just worth pointing out, one of the things about SQLDW, based on the fact that PDW is where it's come from, is that there's various things that don't exist in the MPP environment. One of them is the XML data type. So therefore, when you're having queried for something that would be XML in regular SQL, that comes back just as text, and it doesn't know to give you a link to be able to make it pop out. If you actually run that query through SSDT against SQLDW, it's a bit smarter, and it sees that it looks at what's come back, and it goes, hang on a second, this is XML. I'll let you click on that so that you can actually look at it straight away. But you'll notice there's no link on that. It feels like it's, you know, it feels like it's old school stuff. But that is a regular query plan that you can open in Plan Explorer or save as a .SQL plan, or, you know, all the different things that you would regularly do. It's just that your ability to do much on that is limited because that's on the compute node that it's come from.
So I forgot something I wanted to do, guys. So I jumped ahead. On this query that I ran, we didn't do the explain. So ignore what I just showed you. Let's do explain first here. So if I just add that in front and execute that, I get a bunch of XML. This is the explain that Rob talked about earlier. Now this is at the control node. This is the MPP plan. If I had just turned on show me plan in SSMS here, it wouldn't work. So this is the only way I can get the MPP plan. So this is not a standard plan. If you save it as a SQL plan file, it will not be read properly by Management Studio. So this is where I wanted to actually copy that, dump it into Visual Studio so it'll format for me nicely. So let's chuck it in there. Let's paste it in here and go back. Okay, now I'm not going to spend too much time on this one, but there's a lot of very interesting information in this particular plan. So just up top, you can see it says DSQL query. So that's distributed. It's not a normal plan. You can see I've got 4 nodes. You can see I've got 60 distributions. And there's lots and lots of information around, you know, estimated cost, the number of rows it's going to move around, and so on and so on and so on. Now this is where the statistics become really important. As we said, the autostats work on the individual nodes, but not at the control database. So one of the best practices is to manually create statistics so that the control database has a better clue about what's going on. Because you could have skew, and it could completely underestimate or incorrectly estimate an operation, and you could suffer with performance. You know, it might think it's going to get a few thousand rows, but it gets a few million rows instead. So that statistics is an important step. After you've loaded all your data and everything's happy, definitely have a step to then create stats. Okay, so that can't be opened in Management Studio, but if I take the other one, so that, I'll just remind you how I got the other plan. So down here into monitoring, I used DBCC PDW show execution plan. So that 81 is a process ID. It ran on a particular node, and that is a normal SQL plan. So if
And there's a fantastic page over at MSDN for being able to guide you through all this, for being able to get the individual plans.
That's right.
There's a page on tuning SQLDW queries, which guides you through. It's probably what Barvik used to be able to get that, because it's all the whole thing of
That's
copy
right.
this from there, put that in there, copy this from here, put that in there. Sadly, you can't just do a big join because you ended up with a DBCT call, right? So you go through and you get the details you want, and then you plug it in. You could use dynamic SQL if you really wanted to.
So do we have any open source tools like SQL Century Plan Explorer?
Okay, so the question is, are there, well, you say open source tools like SQL Century Plan Explorer to be able to help with this. Okay, SQL Century Plan Explorer is excellent, but it's not an open
free,
source
but it's
tool.
not
It is
open source.
free.
Yeah.
You mentioned SQL Century as part of the Century One suite. SQL Century's Performance Advisor does have a very good SQLDW and PDW tool. I helped them with it a lot. So it's very good, and it actually monitors the movement and all these kinds of things. Helps you view some of those MPP plans. We're not demonstrating it today because it's about Microsoft, not about Century One.
Good question, good question. So while Rob was answering the question, all I did was save that, so show execution plan XML, save it as a .SQL plan file, and I mean, this is a very basic one, but...
And the one that you've got there is actually getting the execution plan. It's the query for getting the execution plan rather than the query.
Regardless, the point is, I pulled it out from OneNote, and that is a regular SQL plan, and that can be actually looked at. But you can't actually change these, right? You don't have control over what goes on at the compute node layer. And I think, Rob, I'll pass over to you now.
Okay.
I just want to delete, I think your computer's gone to sleep.
Oh no, really?
Yep.
I wasn't expecting to be away from it for so long.
Do you want to put your pin in, and I can delete the password you want me to delete?
I'll do it. I'll open it. Just switch back to the slides.
Okay. I think
So-
we're on 8.
So what we were looking at is
Nope.
no, I'm on 8. You're on
4, I think it is.
no. It's 6
6?
for the
Okay. Third time lucky.
right.
Done.
So I want to spend a bit of time, maybe only about 10 or 12 minutes now, because I'm looking at the clock, and we'll see how we go. Looking at when your choice is heard. I've got a bunch of demos on this, but I might not do them at this point because I know that you're all hungry and looking forward to the closing keynote. Sorry?
Get a link otherwise? Can you get a link of your...
Oh, can I? Oh, the slides will be available by all
Yeah.
means. The demos, it's being recorded. It'll be on Channel 9, I'm sure, unless we say something really offensive. He's behaving himself, so it should be fine.
Yeah, just for you guys.
So yeah, you'll be able to watch the. Look, and I can email me. I'll work out something for you if
Yeah.
it's.
Contact details are at the end anyway. If you want to reach out, find
Yeah.
us on LinkedIn, Twitter, whatever. I mean, we're happy to answer questions. Yeah.
That worked well.
Okay.
That's okay. I've got lots of stuff on this slide to talk about, and then I can always switch another way. That's fine. I need to not fiddle with something. It was good when I had the water bottle, and I could throw the water bottle around. For Christmas, I want one of those little fiddle things that I've seen advertised. So a few spots. Loading data. If you do lift and shift, chances are you're going to be just going into your SSIS packages and changing the destination to be to point at SQLDW and run them. And you know what? It works fine. And when I say fine, I mean like when you say, is this okay, honey? And the answer comes back, fine, right? It will do,
But it could be
but
better.
it's not necessarily what you want. It might not be a win-win situation. It's probably a no-win situation, sorry? You'll pay for it later.
Yes.
Yeah,
yes.
You'll apologise later. So it works fine. It's not awful. It's not actually quite as bad as yes, honey, that's fine. But it doesn't understand the parallelism that you can get with SQLDW. If I think about the old PDW scenario, if any of you have dabbled with that and just haven't admitted to it, using TW Loader was was a very parallel process that would actually talk to the control node, find out where the compute nodes were, and push the data to the compute nodes. It was ridiculously quick. I remember working with clients and we loaded 1 billion rows, and I was like, so how long is this going to take? And they're just like, I don't know, what, 5 hours or something like that. And 20 minutes later, all the data was in there. They're just like, seriously, what the? That was 1 billion rows. Oh, right? And now they've stopped too. That's all right. They stopped really early on that side, these guys.
They have.
Go figure. We started late. We're fine.
We started late. We did.
So
not our fault.
the trick is, as Barbek alluded to, the trick is get the data into blob storage. In fact, now even Data Lake got announced recently. And then use Polybase to pull it in. Polybase actually started in PDW for being able to, with the Hadoop region in mind, but actually connecting to any Hadoop environment, because those big data stores are parallel. It's really nice to be able to say, okay, we've got a whole bunch of compute nodes, maybe only one, but potentially 60. Let's get each of them to get part of the data. And it works really, really well. And you will notice a massive difference if you just take the time to load your data into big data stores, such as blob storage, but even Data Lake now, and then Polybase it in. You'll thank me later for that one.
The AZ copy there that Rob talks about, because you first need to get your data into Blob Store, so that could be a bottleneck itself. So yes, I could get it into Blob Store and then I can parallel load into DW, but how do I get it up there fast in the first place? Now there's a number of options. AZ copy is a tool which will parallelize, so if you have multiple 100 megabits of bandwidth, it will use them all. If not, you can actually ship a disk. So if you know about the Azure import-export service, you can, at a minimum, get a 6 terabyte disk and ship it over to Microsoft for $150, and we'll load it directly into the data center for you. It takes a couple of days. It's an express post kind of thing. It's an encrypted, secure thing. It's not just a, hey, postie, here's my disk. So,
Really paying to build a disk.
sorry?
So like, we need to have that algorithm for the encryption map. This is really pain. I've gone through it.
You've gone through it? Well, do you want unencrypted data floating around? Yeah, so it has to be a little bit painful. Yeah, sometimes it's just not practical. So I was working with a customer a few weeks ago, and we wanted to put 3 terabytes up there, and we calculated it would have taken us 2 weeks to ship it after hours over their 50 megabit link at 3 hours a day. It's just not practical sometimes, yeah. Okay, back to you.
The next point was SKU. Just believe me. In case you hadn't seen it, I've just switched to my machine and using a stylus because whiteboards are really good. They just don't work in a room, so this fits. Ideally, your data is spread out quite evenly, all right? The problem is that quite typically your data is not spread out quite so evenly, and it looks, I'm trying to erase that, it looks more like this, okay? And this is because you've decided to distribute on something which some of the values appear more frequently than others, right? If, for example, you've got a product which sells a whole lot more than the rest, and you've decided to distribute on a hash of that, then that one there will all go to the same one, number 25 there, right? Maybe 24, I can't tell. But you may find that one of your distributions has way more data than the rest. Now, this is actually quite significant because I'm going to use the example of when you're all down the pub. You all go down, you all buy 1 drink each, except for Chris. I don't know, I just saw your name. Except for Chris. Chris bought 3, right? You're all sitting there happily drinking your pints, and you want to leave and go off to, the movie or whatever you're doing next. But Chris has only finished 1 pint and he's still got 2 more to go, right? And you all have to sit around waiting for him to finish, right? You all know this situation where there's that one who just isn't ready yet. Honestly, it'll be soon. I'm drinking as quick as I can, he says.
2 for the road.
Exactly. Elaine wants you to just scull it quicker. Anyway, but this is what happens, right? You've got to still get through the data. You send commands to 60 compute nodes, they all have to finish before the query finishes. You don't want to find that your query is waiting for one of them to finish. But get this, you've got 60. Now understand, the fact that you haven't won Lotto yet doesn't give you an increased chance next time. Do you all understand that? Right? Yeah? You know, that's not how luck works. Right? You know, if you're playing Crossy Road and you've saved up enough coins to get another character, you're no more likely to get a new one than you were last time. Or something, right? I don't know.
Yeah, or something's throwing them off.
So imagine this scenario. Imagine that you have 2% of your sales is on one. You've got 10,000 products, but 2% of your sales is on one. That doesn't sound like much, right? 2%. But you've got to think about it and think that might be the highest number that you've got. That 2% is going to go on to one of the distributions, right? 2%. The rest, can you just touch the rest is going to be distributed pretty evenly, right? You got 60, that's like 1.6% each, right? You've only got 98% of what you had to distribute across 60, it's still about 1.6, right? But all of a sudden, one of them's got 3.6, which is more than double any of the rest. Just because one of your products had 2%, 2%. I'm not talking 30%, I'm talking 2%, and all of a sudden your query's running taking twice as long to run because of SKU. Because it's got to wait for Chris to finish his second pint. Right? And the third one. It's Chris, it's probably 5. But anyway, I've never met him before, I'm sorry. But you understand, right? SKU is a thing. I was going to quickly run a demo, but I won't bother. You could also just do this by picking something which has not that many different values. I decided to, it's ridiculously well distributed, like the database that he's got. But I said, oh, what if we actually distribute on the quantity of the line items in the order? The number only went up to 50. Now, if I'm going to distribute 50 things across 60 distributions, 60 databases, at least 10 of them are not going to have any data, right? And probably I'm going to get some hits. I am going to quickly show you this. If I run, I've got a few, I've got this one here. I basically had said, let's recreate this table as SKU line item, distributed on hash of quantity, and then when I say dbcc pdw show space used, I don't use capital letters. And I've got my results in text so that I can, so that it's larger. The number of rows, look, here is 1.2 million, here is 1.2 million, here's 1.2 million. This one's about 2.4 million. Guess why? 2 of them ended up on the same distribution. Huh. If I keep going down, this one's got about 3.6. So all of a sudden, my query is running, it's got to wait for the guy with 3 pints. Because 3 of my values got pushed onto the same distribution. If you don't have a large enough, large enough proportion of a large enough number of distinct values, distributing on that isn't going to cut it. But yeah, it'll still, you can distribute on anything. It doesn't care. It's just that you'll suffer for it. The number 6, number 5, 6? 6, terrific.
Yep.
So SKU, be wary of that, okay? Have a look to see what's going on. Joins and aggregations. We've already mentioned the whole thing of being able to making sure that your joins don't need to move the data across from one spot to another. Too much data movement will hurt you. Monitor to see what's going on with data movement, and think about the queries that you want to run. Because honestly, you're the data professional in the room, right? Not this room, in the room where your client is, or in your organization, or whatever. You're the guy, right? It's a generic term. You're the guy too, Lace, and you, Elaine. Elaine's a SharePoint person. She's not a data person. She's leaving her job anyway. Elaine's just joined Microsoft. She'll be there soon. Next week? 27th.
Cool.
So congratulations to Elaine. That's fantastic. Don't clap. Everybody will think we're finished. They'll open the doors for everybody. Yes, you're right. Elaine used to work at the same company as, and clearly, but you sat on the edge to make sure she couldn't sit next to you. I think it's you that's bitter, not her.
Gary,
just saying. Hashtag just saying.
Gary, you're moonlighting as a bouncer then. You're moonlighting as a bouncer then.
So you know the kinds of joins that are going to be used more often. You know the behaviors that are going to be seen. You know what needs to happen with the queries that are running against this box. Okay? You can plan for that and work out what's going to work. In fact, the more you denormalize, the fewer joins you need, and you can actually save some effort there too. Don't be afraid of going, you know what, it'd be quite handy if we kept the business key of the product as well as the surrogate key of the product in the fact table, even maybe the name of the product, because if that's all we're joining for, in the fact table, we can avoid those joins, store it all there. Sure, it takes up more space, but space is remarkably cheap. It's across 60 boxes, for crying out loud. It could be worth doing. Analyze to see what's going on and plan accordingly. You've got to remember what happens with VertiPack, right? In VertiPack, inside Excel, that's column store indexing just within Excel. In Excel, you just denormalize, right? But actually, it's also, I mentioned column store, it's also worth being aware that column store doesn't do everything well. Column store doesn't like, columns that have a large number of different string values.
High cardinality, yeah.
You may want to find that you put that data into other tables and maybe even consider row store for them. I mean, Barvik made all those tables column store. I looked at that and just went, yeah, those ones are like 10,000.
Yep.
Those should be row store. You can index that more nicely. It's fine. It's totally fine.
Quick question.
Yeah, quick question.
What's your recommendation on hitting the concurrency limit?
Okay, Leslie's asking about the concurrency limit, and if you hit that, what are you going to do? That's a point where I would say, if you're having trouble with that, look at the DWU option that you've got. But it also comes down to being able to look at how chatty your applications are and so on. You may find that there's all kinds of strategies to be able to reduce how many queries are running. But as far as the overall concurrency, it feels small, but you'll actually find that you probably don't hit it as often as you expect to hit it. If you, yes,
well,
if you are already, then DWU
I want to add more
good.
to that. Something that we've come across is, for example, sticking Power BI directly on top of SQL Data Warehouse. Let's say you have a report page with 12 elements on it. Each one of those is going to fire off an individual query to SQL DW. So that one report is taking up 12 slots out of your potential 32, if you're scaled up high enough. So the recommendation we've got, and we give people, is don't put Power BI or clients like that, chatty clients, directly on top. It's not built for that type of interactivity. So put analysis services or some other kind of cached layer on top. So just be aware. Yes, if individual users are connecting and running queries, if you've got analysts and things, you'll probably be fine. It is fast, so you shouldn't have queries running for hours and hours or minutes even. It's possible, but but for something like that, you just need to be careful and know that it's not designed to handle that kind of super chatty workload. If 10 people fire up dashboards at the same time, some of them are going to be waiting. Power BI, for example, will just time out, and you'll get all those little errors on each visual. Yeah, so just be aware.
Time's running late.
Yep.
We'll see how we go. Over partitioning. This is quite a big one because people feel like partitioning is really good, especially for manageability and so on. They just go, yep, I want to have a partition per month. I want to do nice switching and all that kind of stuff as I'm loading the data in. But you need to be conscious of what the impact on your column store indexes is around that. Column store data is fantastic. It's massively compressed and so on. And if you remember in 2012 when column store came in, it was read-only. In 2014, we got to make a clustered column store index. In 2016, we got non-clustered column store indexes, and that was really handy. But still, column store, the reason column store started in read-only is because it doesn't do changes very well. because when it compresses it, just like if you've got a zip file, you don't want to change anything that's inside the zip file, that just gives you pain. But because of that, any changes that are going on go on inside the Delta store, as you're probably aware, and that is not compressed, and it's not nicely indexed, and it's probably not ideal for your queries. So if I quickly switch back to mine, and I want to show you, no, 8, this one, 8. I want to show you what happens. I created a table called RF59 million, and I'm just doing a count star, and it's still running. It's been running for a minute 44, 45, I can see down the bottom. I know you can't, but it's been running for a while, and that sucks. And the reason why is because if I actually go and look at how these are distributed, it's probably not that one actually. No. If I actually look at how the data is distributed, I would see that that I would have almost 1 million rows in each database, but the row group is open. It's the Delta store still. It hasn't reached enough to bother compressing it. And if I failed over to the next month, not failed over, if the next month came around and I started to use a new partition, they might never actually compress. And my performance might be like this. Oh, look, it finished 236, right? I made another one, which I just created quickly, right, like that. If I count this one, it's that quick. Did you see how quick that returned? I know you're not interested in the answer, but it was quick because it's using column store compression. I made this one, which is still slow, I think. Yeah. So that I could use the thing alter index all on RF59.2 with rebuild to be able to say rebuild those column store indexes. This is going to take a moment, but it's going to give me the performance on that like this one because it will be compressing it. The reason why it's already compressed the one that I just created from scratch is because of the way that CTAS works. When you create a fresh table, it goes, oh yeah, and I'm done, and I'll compress them. When you're putting data into an existing table, it figures that's going to go on forever, and then at every time it gets to 1 million, it's going to go, okay, great, and compress, and keep going, and okay, great, and compress. If you're not keeping on going because you're over-partitioned, you'll have pain. I have another point around statistics and cardinality, which is around the thing of whenever you create a table, please create stats yourself on the control node. You've got to put a create stats statement in there on pretty much every column that you're ever going to query, because otherwise the control node doesn't know how many rows there are. And that plan where it says, oh yeah, I don't have many rows in this table, I'll pick them up and broadcast them across all the different databases so that they can all join to it. If that suddenly got orders of magnitude more, your query is going to be slow, right? Based on time, I'm not going to demonstrate that, but Barvik, over to you.
So that kind of wraps up the talk. So thanks for sticking around, guys. Just to summarize, we've covered all of this, but the main points: don't accept the defaults. They're, in some cases, going to cause you pain, as we've said. Know the impact of your choices, so hashing, partitioning, and how that actually maps to the distributions. There are best practices around this. So as Rob said, I picked up most of my demo from the documentation, so you could follow along and actually get the same kind of experience. So all that stuff that I had is actually documented by the product team. And something they've committed to is actually trying to improve documentation as of late. So it's pretty decent. There's even little boxes where you can just hit copy now on the web page and it copies the code for you. That's good.
This is the best practices page. It's really useful. Go there, read through it and so on, and look at all the documentation there, because it honestly is some of the best documentation for any of the Azure products. They've got the guy who's in charge of making sure that this is up to date is he knows what he's
on top of it.
Doing.
Yep. So the other point, keep abreast of announcements. So as I mentioned, stuff is being worked on. You know, some of the, let's call them weaknesses, are being worked on. The product team acknowledges them. So it is a fantastic platform, but it can be better. So keep abreast of announcements. Like, for example, until recently, the DMS service had a 32K row limit. So that's pretty much quite a big blocker. Now it's 1 megabyte, which is massively, massively bigger. So, you know, and that was just, what, 2 weeks ago?
Yeah, and that affects your table design, because if you had a row that was too big for 32K, you'd have massive performance impact. Now that it's a meg, it just, you don't have that same kind of limitation on your table design.
Yep. Stats we've talked about. Monitoring, again, those are some examples over there. But now you understand that you can actually monitor from the queries coming in, down to the individual steps in the queries, down to the D-SQL plan, and then also looking at the individual node plans as well. And there's a whole bunch of additional system views. So there's a page somewhere. If you just search for monitoring SQL DW, there is a docs page that actually lists every single DMV that will give you information on what's happening under the covers.
You won't find us in the speaker lounge because the event's pretty much over, but you may see us in the next hour or two.
We'll hang around if you want to chat, obviously.
I skipped through the questions slide because you've been asking questions, and that's fine. Our email addresses are there. You can also do an internet search for us if you have trouble. Is that the right word to use? Bing. You can Bing for us. It doesn't quite work, does it? But thank you very much for coming. If you are having pain with SQL DW, I hope that this has helped. Feel free to come and pester us for as long as you need. We have flights to catch, but that doesn't matter.
I only fly out at 8, so I don't have any choice.
Yeah, I'm 3:45.
Come ask me questions.
Thank you for coming, everyone.
Thanks, guys.